Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Christopher Sawicki, and I am your host for episode number 25. Today, I'll be discussing the chemistry of lightning. Lightning, as we all know, are those big bolts of electricity shooting down from the sky. Lightning also gives off a smell and a color, and I will be explaining all of this and why it happens using chemistry. Before I explain the chemistry behind lightning, there's a few concepts that you need to understand first. For example, ionization. This is the transfer of electrons to form an ion or from an ion. Also, intramolecular forces, which are the attractions between atoms in a molecule. And lastly, intermolecular forces, which are different from intramolecular forces. Inter is the attractions between entire molecules or components. You are now ready to understand the chemistry behind lightning. Lightning is caused by clouds having an overall charge. This is caused by the charges not being balanced throughout a cloud, which is caused by updrafts, which are currents of air moving upwards, which sweep positively charged molecules to the top of the cloud. Consequently, ice, which has a negative charge, is also moved to the bottom of the cloud. And this negative charge on the bottom of the cloud causes electrons to want to move to positively charged ions. This is because of intermolecular forces. Molecules and components all want to be neutral, and when ions have a negative charge, they want to find positive ions so they can give their electrons to them. Because there are so many negatively charged ions in the bottom of the cloud, these electrons all leave those negatively charged ions and find positively charged ions to move to become neutral so they can be happy. These intermolecular forces cause attractions between the negatively charged ions in the bottom of the cloud and the positively charged ions on the ground. So these electrons create a big discharge which can contain billions to trillions of electrons, and that is what we call lightning. Lightning can contain 1 billion volts of electricity and up to 5 billion joules of energy because of this discharge, which is caused by the unbalance of charge at the bottom of the cloud. As electrons move down through lightning, they also crash into more molecules in the air, which knocks the electrons off of those molecules and creates an even bigger discharge for the lightning, which moves to the ground. As we all know, lightning is more attracted to metals on the ground than other things. This is because of intramolecular forces, which are the attractions between atoms in a molecule or compound. There are three types of intramolecular forces: covalent bonds, metallic bonds, and ionic bonds. Metals have metallic bonds. Metallic bonds are made up of metals which have the least full valence shells because they have the least amount of valence electrons in those shells, so they can't bond together to create full valence shells. Instead of doing that, they create a sea of electrons, which is resulting in a lot of positively charged ions and a bunch of electrons flowing through those positive ions freely. Because of this, the electrons from lightning are more attracted to metals because of those positively charged ions, and they can flow freely through that metal. Other things, not metals, have covalent bonds or ionic bonds, which valence shells are completely full because electrons are shared between the atoms. Because of this, there are no positively charged ions in covalent bonds, and the positively charged ions in ionic bonds are neutralized by the transfer of electrons from a negatively charged ion to the positively charged ion. This is why metals are more attracted to lightning than other things. Lightning also gives off that smell of thunderstorms. This smell of thunderstorms is a result of ozone in the air. As lightning travels down, the electrons split the O2 molecules, which creates two oxygen atoms. These two oxygen atoms then bond with other O2 molecules, creating ozone, which is O3, and this ozone creates that smell of thunderstorms. Lightning also creates a bluish-violet color that highlights the lightning bolt. This is caused by electrons from lightning ionizing O2 and N2 molecules. These molecules then become excited and they take on a different color when in this excited state. Lightning also produces an enormous amount of heat. This heat is caused by electrons in lightning carrying the heat. Lightning can be up to 54,000 degrees Fahrenheit. That is 6 times hotter than the sun. This is all caused by intramolecular forces. Air, which is made up of gases, is a poor conductor of electricity. This is because air is made up of gases which have covalent bonds. These covalent bonds are made up of two gas molecules which have nearly full valence electron shells, and because of this, they share their electrons in the valence shells to create full electron shells. Because of this, all of the atoms in these air molecules are neutrally charged, and they repel these electrons from bonding with the air molecules. This causes air to be a poor conductor of electricity because they repel these electrons. Because of this, there is a greater resistance to electrons moving through the air, which creates heat, heating up the molecules around lightning and the electrons in lightning itself, which makes it be able to be that hot. And that is the chemistry behind how lightning is formed and also the smell, color, and heat of lightning. I've always thought lightning is very cool, and lightning fascinates me because clouds, which seemingly form out of nothing, only evaporated water, produce lightning bolts with billions of electrons, creating enormous amounts of volts of electricity and energy, which is enough to even kill people. 2,000 people die a year due to lightning, which forms out of water molecules just moving around in the air. It has always fascinated me, and I have always thought lightning is very cool, which is why I wanted to get to know more about it and why lightning is caused. Thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit hvspn.com.